All right, so we're going to talk about the very last type of quadrilateral. So we've already talked about parallelograms, where we said both pairs of opposite sides are parallel. We talked about specific types of parallelograms like squares and rectangles, rhombuses. We talked about trapezoids, which are also quadrilaterals, but where only one set of sides is parallel. And so now really the only other possibility, besides just saying it's nothing special, is to say, well, what if none of the sides are parallel, but consecutive sides are supplementary. I'm sorry, consecutive sides are congruent, which is what's happening here, right? So a kite is our last possible, or our last quadrilateral that we're going to discuss, and it is also a quadrilateral. Okay, but two things are true about this quadrilateral. We're going to say consecutive pairs of sides are congruent to each other. So if you take a look at my picture of my quadrilateral, I have the two sides on the left equal, the two sides on the right equal, and if you remember, consecutive means ones that are right next to each other, just like consecutive numbers are numbers that are right next to each other. Consecutive sides are two sides that are right next to each other. So we're saying the consecutive sides are equal, okay? So every side is equal to one other side that it is connected to, but the opposite sides are definitely not congruent, right? Because if we start doing that, then we get into this place where, you know what, maybe it's a square or something else, or a parallelogram, right? So we're going to say if I go through the shape, okay, which if I start over here and I travel through to the opposite side, they are not parallel. So I have a single dash and a double dash, which means not congruent to each other, right? So when we look at kites, there are really no special properties because we lose all the parallel lines that we've been using to say a lot of interesting things about trapezoids or parallelograms or other shapes. So when we're looking at kites, really the major focus is going to be on the diagonals, right? So here is a property of a diagonal, and we're going to take this a little bit further, right? This theorem is saying if I have something like this that is a kite, right? So because it's a kite, what we can say is that the consecutive sides are supplementary. So in our particular problem, here's what we're going to say is supplementary. Okay, let me get rid of that extra line. All right, we're going to say that the top two consecutive sides are equal, and the bottom two consecutive sides are also equal. So that's my kite. Okay, so this is about the diagonals, and they're saying if you draw both of the diagonals, which remember connect two two angles through the triangle, that if I draw both of them, that they are going to be perpendicular to each other. So what I'm going to be able to add to my picture is that this, right, everywhere is a right angle. Okay, so we get that right angle through the middle of the shape. Okay, something else interesting happens as a result of this. This would be like a corollary. Remember, corollaries are just something else that's true because this theorem is true. The other thing that ends up happening is, if you take a look, if I just kind of focus on this top triangle right here, and I have an exact copy on the other side, I end up getting congruent triangles, right? So if you notice, I have a right angle and a single dash. If I go over to the other triangle, I have a right angle and a single dash, and they share a side, right? So I'm going to add another line here and say this middle side is shared. So by what we know about congruent triangles, this is a hypotenuse leg situation, right? And so here's what this means. This angle right here and this angle right here are corresponding parts of congruent triangles. So I can say that they are equal. And on the bottom, I get the same situation happening. I have it's the exact same situation, but I have double dash, but I'm going to end up getting that these two angles are equal to each other. Okay, so I'm actually going to get an additional piece of information besides the perpendicular in the middle. I can say that the top and the bottom, or the two sides in the congruent triangles, those angles are going to be bisected as well. So we're going to use that fact too. So it's important to notice that we're getting two different cases of hypotenuse leg congruent triangles, and that's going to be something that you'll use to maybe find some additional information about the shape. Okay, so let's put this into practice and see what we can figure out. So if I give you this problem, we're saying there's this quadrilateral DEFG, and it is a kite. And they're telling us that this one little angle in here is 52 degrees. And they're saying based on that and what we just talked about, that you should be able to find the measure of all of these other angles. Okay, so if we're going through this, we're going to be able to say right away that angle 1 is 90 degrees. That is at the intersection of diagonal EG and diagonal DF. So I'm going to say angle 1, 90 degrees. Okay, so I'm going to try to squeeze that in here so we can see it in the picture. So if you notice, again, I have this triangle here. right? 90 and 52 are a part of this triangle with angle 2. So I can say angle 2 should be, it looks like 38 degrees, okay? Because if I add together 38 and 52 and 90, I'm going to complete that triangle and have all 180 degrees that have to be there, right? If I go to the one on the left, I'm getting an exact replica of the one on the right. So if this little angle up here is 52, the one right next to it is also 52 degrees, okay? So I'm going to be able to use those properties and what I know about triangles to fill in any of the blanks. So let's take a look at one more example like this. And this, again, this is really the only major application for kites, right? So same situation happening here. I'm going to be able to look at this. It's turned on its side, but we can definitely look at this and see that KL and KN are equal size. We're sharing the one in the middle, okay? And it looks like angle 1 is an angle at the intersection, so I'm going to say that that is a 90-degree angle. Okay, so I'm going to put a little 90 in here, and I have 90 and 36. Well, if this is 90 and 36, that means that this little angle over here would have to be, it looks like 54 degrees, okay? Which, unfortunately, that's not one of the ones that they asked for, but at least I'm getting some more information. So what I know, again, is that this bottom triangle, okay, is equivalent, it's congruent with the top triangle because of HL, right? If I put a 90-degree angle here as well, I have a single dash, which means that KL, the hypotenuse, is congruent to KN, the hypotenuse. There's my right angle, and I have this shared little piece here. So I'm going to be able to say that corresponding parts of these two congruent triangles are all congruent, which means angle 2 is also 54 degrees, and angle 3 is also 36 degrees, right? So use those triangles to your advantage and use all of these HL situations plus our property about diagonals being perpendicular, and you can fill in all of the angle measurements inside of this kite.